So far in the C programming language book, we have covered preface to the first edition and introduction. Today we'll be looking at a tutorial introduction, chapter 1. Let us begin with a quick introduction to C. Our aim is to show the essential elements of the language in real programs but without getting bogged down on details, rules, and exceptions. At this point, we are not trying to be complete or even precise, save that examples are meant to be correct. We want to get you as quickly as possible to the point where you can write useful programs, and to do that we have to concentrate on the basics, variables, constants, arithmetic, control flow, functions, and the rudiments of input and output. We are intentionally leaving out of this chapter the features of C that are important for writing bigger programs. These include pointers, structures, most of the C's rich set of operators, several control flow statements, and the standard library. This approach has its drawbacks. Most notable is that the complete story on any particular language feature is not found here, and the tutorial, by being brief, may also be misleading. And because the examples do not use the full power of C, they are not as concise and as elegant as they might be. We have tried to minimize these effects, but be warned. Another drawback is that later chapters will necessarily repeat some of this chapter. We hope that the repetition will help you more than it annoys. In any case, experienced programmers should be able to extrapolate from the material in this chapter to their own programming needs. Beginners should supplement it by writing small, similar programs of their own. Both groups can use it as a framework on which to hang the more detailed descriptions that begin in chapter 2. So we'll be getting started with section 1.1, which is getting started. The only way to learn a new programming language is by writing programs in it. The first program to write in this is the same for all languages. It is the legendary print the words hello world. Usually this would be your first program in most of the languages. You need to print this set of characters, a character string. This is the big hurdle. To leap over it, you have to be able to create the program text somewhere, compile it successfully, load it, run it, and find out where your output went. With these mechanical details mastered, everything else is comparatively easy. So to print a statement, which looks easy, what we'll be doing is we need to write the program, which involves knowing the syntax of the language. Then we need to compile it. We get the machine code. We need to load it to the system. We need to run the executable file, and then we need to observe the output. Where will the output come? For us, we rather assume always the output comes on a screen because that is what we mostly see. But then the output can go to a file, the output can go to a button, the output can go to any sort of mechanical system. So when we want it to display on a screen, that is a set of different tasks in itself. So when we are printing this hello world statement, we'll be learning all of this in a single program, and this will be useful going further. In C, the program to write or the program to print hello world is hash include So if you write this set of statements in a text file, you have a C program. But then that is not the end of it. We only got the text file to write the C program. We need to compile it, we need to load it, we need to run it, and then we need to see the output. But then let us first understand what the C program does. Just how to run this program depends on the system you are using. As a specific example, on the Unix operating system, you must create the program in a file whose name ends in a .c. So file name .c is the extension of the file. It is similar to .txt, .pdf, but then this is a file you need to create in a text editor and save it as .c, such as hello.c, then compile it with the command cc hello.c. So this particular file that we have written, we can save it as hello.c in our Unix machine. Then in the command prompt we can, so the cc is a command saying C compiler, and we are executing the compiling the hello.c program. If you haven't botched anything, such as omitting a character or misspelling something, the compilation will proceed silently and make an executable file called a.out. So this text file will be converted to a binary file after compilation, which will be written as a.out. This is a binary mission readable code, executable code. If you run a.out by typing the command a.out, it will print hello world. So the final display would be hello world, which we have written in our program here, hello world. On other systems, the rules will be different. Check with a local expert. Now for some explanation about the program itself. A C program, whatever its size, consists of functions and variables. So any C program has a function, has a variable. A function contains statements that specify the computing operations to be done, and variables store the values used during the computation. C functions are like the subroutines and functions of Fortran, or the procedures and functions of Pascal. So if Fortran is another programming language, in that we would have subroutines and functions, or in Pascal it is named as procedure. C functions are similar to these, but it is not the same, of course. It is a different language. It's similar, just to give you the idea. Our example is a function named main. So going back to this is our function in our example, and this is the set of statements that will be computed. And there is no variable here as such. But in our example, there is a function called main. Normally, you are at liberty to give functions whatever names you like, but main is special. Your program begins executing at the beginning of main. This means that every program must have a main somewhere. So this is an important part here to know that there is a statement. Every C program must contain a main function. What does this mean? So we know that C programs written are compiled to binary machine code. For the compiler to begin the program execution somewhere, so we know that compiler executes the program, but where should it start? It should start execution of the flow of statements or the instructions somewhere. So every C compiler, the rule written is that begin your compilation in the main function, and the set of statements that will be followed computed first is whatever is written inside main. So every C program must contain a main function, and their program execution begins with the first line written in the main function. Main will usually call other functions to help perform its job, some that you wrote, others from libraries that are provided for you. The first line of the program hash include stdioh. io.h tells the compiler to include information about the standard input-output library. So the thing is, you have to include main in all C programs where the compilation process will begin, but then you don't have to write the entire functionality of your code inside this main program. What you can do is you can define another function which performs the actions that you want to perform, you want the computer to perform, and then call the function name here. You can call the function inside main, just that the compiler begins execution inside this main function, but then the function call can happen and it can go somewhere else. And the second part is you don't need to write all the functions. Some functions are already provided by the C program. For example, the printf statement that we saw earlier, hello world. This is in itself a function which you didn't write. This was provided by the standard library. And how does the computer know to include the standard library? For that, we are using the hash include std input output dot header file. This dot h signifies it is a header file. Dot c says it is a source file. So if we are going back to our function that we wrote here, we can see that we are using this hash include stdio.h in the first line of the program. That tells the compiler to include the information about the standard input output library. This line appears at the beginning of many C source files. The standard library is described in chapter 7 and appendix B. We'll be seeing that later. One method of communicating data between functions is for the calling function to provide a list of values called arguments to the function it calls. The parentheses after the function name surround the argument list. So what they're trying to tell us, when you're calling a function inside pset inside main, you can write the statements. And here, if you're calling a function, if a function, it will be more useful if you are sending some parameters inside the function. This is called as arguments. So one method of communicating data between functions is for the calling function. So here this is the calling function. This is the function getting called inside this calling function. The calling function is sending some input to the, let us say if we are using printf function, we are using some sort of the list of values called arguments to the function it calls. The parenthesis after the function name, these parentheses, after the function name surround the argument list. In this example, main is defined to be a function that expects no arguments, which is indicated by the empty list. Uh, so main does not have any arguments, empty list. The statements of a function are enclosed in braces. So we saw that the statements of a function main were enclosed in braces, curly braces. Here the statements are written. We earlier saw that a statement is a set of, we haven't written it here, but the statement is a set of expressions or function calls, and expression is or function call, and a function call is, you have already seen it, an expression is operators and operands combination, and these operands can be the variables or constants, and these variables or constants are of the defined data types or derived data types. The statements of a function are enclosed in braces. The function main contains only one statement. So in our example that we are seeing, it contains two statements, printf and return 0, statement 1 and statement 2. It is returning 0. The 0 is a error code. If you return 0, it means the program executed successfully. This is a good practice which we'll see later. A function is called by naming it, followed by a parenthesized list of arguments. So this calls the function printf with the argument hello world, and this is enclosed in the set of braces to say it is an argument. So calling a function can get confusing. The term might get confusing. What it basically means is to call a function, all you have to do is write the function name followed by the argument bracket, list of arguments, and this is how you call a function. Printf is a library function. Library function is defined in the standard input-output header file. Library function that prints output, and in this case, the string of characters between the quotes. A sequence of characters in double quotes like hello world is called a character string or string constant. For the moment, it is called the character string. Or string constant. These may sound the same at first, but then it holds a significant value. Character string, we already saw what it means. It means basically a set of characters are connected with a string and that forms a word. And hello is a set of characters, but then it is attached by a string to form a word. This is a character string. But what does a string constant mean? Constant signifies that it cannot be altered or it cannot be modified. We can, in other instances, we can see that if there is an integer variable called as n, which holds some value. In the program, in the further statements, we can modify it as n equal to 10, but then we cannot do it with the string constant. It cannot be modified. For the moment, our only use of character strings will be as arguments for printf or other functions. The sequence, so we missed a sequence in our program. We could have included in the hello world program, we could have included a slash n at the very end. We'll write it somewhere again. We see the empty list of parameters. We have one single statement called printf, which holds a argument inside string constant argument inside its parameterized uh, argument list. We have the slash n which we included now, and this is a statement, single statement. We are ending our program inside, and the statement is enclosed by set of curly braces, which and we are calling this function printf inside our main function, and our compilation begins at main. So here, what we wanted to explain is this slash n is a escape sequence. The sequence slash n in the string is a C notation for new line character, which when printed advances the output to the left margin on the next line. So what they're trying to tell us in the output window, when hello world is displayed, the cursor won't stay here, rather the cursor goes back to the new line. This going to the new line is represented by slash n. So when we are writing in text editors, we press enter after a single line and it goes to the new line. But then how does the computer know that there is a new line after this end of line? So that character is represented by slash n. This is also provided in the ASCII character set. If you leave out the slash on a worthwhile experiment, you will find that there is no line advance after the output is printed. You must use slash n to include a new line character in the printf argument. If you try something, uh, so what the human tendency to do this hello world, we need a line after this, and this is John. So if we write this way, the computer doesn't know what this space is. The computer doesn't know what this is. All the computer understands is it should be in a character string should be in a set of double quotes, and it should be a argument to the function printf. So that is how the C compiler rules are written. Hence, to add this new line to our output, we need to use the slash n character. The compiler will produce an error message. Printf never supplies a new line automatically, so several calls may be used to build up on an output line in stages. Our first program could just as well have been written as. So just to recap, the hash include part includes the information about the standard library. Main is a defined function named main that receives no argument values. Then we have the statements of main that are enclosed in braces, and main calls library function printf to print the sequence of characters. Slash n represents the new line character. Now, printf never supplies a new line automatically, so several calls may be used to build up an output line in stages. So our first program could just as well have been written as hash include So what we are trying to do is, since printf does not include the new line character automatically, we are trying to demonstrate this aspect of printf function. So this output does not give us hello and in the world in the next line. Rather, what it does is it prints hello world in the same line, since printf does not automatically include the new line character. Notice that /n represents only a single character. An escape sequence like /n provides a general and extensible mechanism for representing hard to type or invisible character. Among the others that C provides are /t for /n we have already seen. Then we have /t, tab space, the one which usually gives four spaces, white spaces, and new line goes to the enter. Then we have to print this backslash itself. We have /b equal to backspace and double quotes. So why this is required is in our hello world program, hello world John. So if we want to print this, if we include it in a parameterized set of statements inside printf, this gets printed and this throws an error, because what it does is it considers this double quote as the end of the string. So if we have to use this double quote, if we need to print the double quote, we need to use the escape sequence. And the other most important part that they have mentioned is the slash or anything in this. The escape sequences are single characters. What it means is, if you are printing the length of the string, length of this is 1, 2, and 3. The length is equal to 3. It is not equal to 4. The slash and n are not separate two characters. It is one character, and it is given in the ASCII sequence. We have completed the section 1.1 in our lesson plan. Next we'll be looking at 1.2.